Okay. Yes. If you want, you can get a recording later. That's fine. But we don't have YouTube live anyway. Hari? Hari? Okay. Then also before we start the today's session, thank you for joining today because this wasn't a pre-planned session, right? So I don't expect a big participation or considerable participation today, but doesn't matter. A huge thank you for the students who are joining even today, right? Because this is a unannounced, not a pre-planned session, right? Okay, that's the first thing. And if someone is wondering what's happening today, who doesn't know what exactly is happening today, just join because the Zoom link was sent. Today is the third day of our free seminar series, which is actually an extra session. This is an extra session. For day 2, we were planning to finish electrochemistry entirely, but we were unable to do so. Therefore, I arranged a session. So we had day 2 on last Tuesday, right? If I'm not mistaken, we had day 2 on last Tuesday, and today we are having the part. We are having this session to cover the parts which we were unable to cover on that day, right? And also to complete few questions on our tute as well. So the tute has been sent to the group. I think everyone has a hard copy of the tute. Don't use soft copies whenever you are doing questions or whenever you are studying. That's a very important thing which we teach in A levels. Right? So we'll do a few questions, or we'll try to do the entire tute, but I'm not sure. But at least we'll do few questions from the tute as well. Before that, we need to finish all the theory parts which we were unable to finish on day 2. Hari. And also I hope that all the students here who are joining have watched at least 60 to 70% of the day 2 recording, or have joined for that session live, because honestly, without not knowing the knowledge, honestly without not knowing what we did on day 2, it won't be that effective listening to what I'm teaching you today, because all 3 parts of your electrochemistry unit is actually connected to a certain level. Hari? Therefore, keep that in mind, keep everything completely understood on what we are doing, and what you should be able to know before joining today, before actually starting today's session. Hari. And it's 10 minutes past 9, so we'll start. And I'm planning to finish the session at around 12 p.m. Hari, 12 p.m. we'll finish the session. Hari. And also, as usual, if you have any issues, if you have any doubts, you can put it on the chat. Hari, if anything needs to be clarified, you can again ask. Hari, everything. I hope that's clear then. Hari, right. Right? Okay. Good. Then let's start. Hari, then let's start today's proceedings. First of all, I'll give you an idea on what we have to teach, what we have to learn, and from my side, what I am supposed to teach today. Hari, you can, what we are supposed to teach today. And yeah, okay. So the first thing is that I will start explaining applications of electrolysis. We actually finished all the theory of electrolysis, but I couldn't finish all the applications of electrolysis. There are a few applications on your on your textbooks actually, but the common explanations which they ask and which they have explained on your textbooks is the down cell, which is for extracting sodium, and the other one is electroplating. I taught you about the down cell. We explained how it works and what the reactions are and how to derive those on day 2. And I couldn't explain what is electroplating. Therefore, I will be starting explaining what electroplating is. There are a few more applications given on your textbook, but I won't go into details because those things haven't been explained, and in your paper also those things won't be asked as questions because those things haven't been explained on your textbook. So these 2 are the main applications, down cell and electroplating. I taught you down cell and we have left electroplating. Hari. And afterwards I will be starting the third main topic. The first main topic was electrochemical cells, which we completed. The second main topic is electrolysis or electrolytic cells, which we will be completing with this part. And then the third one will be corrosion of metals. Right? The third main part will be corrosion of metal. So I will be finishing this part entirely. Under this, mainly we will be focusing on rusting of iron, which is the type of corrosion which happens to iron, Fe, iron. That will be taught completely. We will be revising all the experiments, all the equations, and how to prevent corrosion, how to prevent rusting. So that's the plan for today. Is it clear? We will be finishing electroplating. With that, second main topic will be finished, and then we will be starting the third main topic fresh. So we haven't done anything regarding the third main topic. We will be finishing it entirely, and afterwards, in the final hour, we will start doing the question too. Hari, I don't know whether it's for the final hour or 1.5 hours. We'll see. Hari, is that clear? If everything is clear, we can start working on it. Hari, okay. Then put the topic. Now, actually, we have written the topic. So the topic for this part, which would be applications of electrolysis. Under that, the first part which we discussed was downcell. The second part, put 2 or whatever the number according to what you have written. So write it in a way which makes sense for you. No need to think about a proper note now. It's not necessary now. The note should be on. The only requirement for your note should be that it should be understandable. If you can understand it, then that's it. So put a topic and write electroplating. Electroplating. Has anyone seen electroplating, or does anyone know what electroplating is? Can someone explain? Or either you can give an explanation on what electroplating is, or else you can say, okay, I don't know what exactly electroplating is, but I have seen electroplating. Can someone give me an idea on what electroplating is and how it is being done? What are the examples for electroplating? Has anyone seen electroplating? Just to refresh ourselves for the icebreaker because now නිදිමත දන්නෙත් නැහැ. හරි. දම්බන්ටක් ගාලා. What's electroplating? Okay, so there's one answer saying galvanizing. Yeah, that's one type of so one example for electroplating is galvanizing. Then there's another question, what's galvanizing? We'll discuss that. Hari. Okay. What else? For galvanizing, you can use electroplating, but we'll learn galvanizing later under this corrosion part, which is used as a method of preventing iron rusting. But yeah, that's true. What else? What else do we have? What other answers do we have? Okay, true. We have wait. Yeah, there are a lot of answers. Galvanizing, plating, zinc on metals, gold plating. Okay, good. Electroplating is the process of plating, right? Plating, metal, coating, covering. Yeah, you have a basic idea, right? You have a basic idea on. Okay, on regarding other lessons, we'll discuss it later. Not now, Hari. Plating a less reactive metal on high reactive metal like Fe. Applying a metallic layer on, yeah. So you get the idea, is it clear? Now, most students know what electroplating is. Actually, they have a rough idea. It's basically applying or coating a metal layer on another metal. That's basically what electroplating is. Now, if you have a layer of, let's say, copper, if you have a copper block of copper, then you can coat another, or even you can even coat copper as well. It's not necessary to be another or a separate metal. It's not compulsory. If you want, you can apply gold, zinc, or else you can apply even copper. If you want to apply more copper, then you can do it. Again, that's electroplating. That's possible. So that's the idea of electroplating. And they have a few examples as well. Galvanizing, we'll learn that later. And you can do gold plating. Now, if you don't know what gold plating is, when you are doing shopping, when you are shopping, inside in front of those imitation, or not you can't say imitation, some smaller scale gold shops, not branded big gold shops, not reputed ones, normal නිකන් ඔය පොඩි කඩ තියෙන්නේ. In front of those jewelry shops, there is a person with a sink, sort of a sink kind of an item, and then that person is doing something. Observe that. He is actually gold plating. That's again one type of electroplating. What he does is, he has this, let's say, jewelry, let's say it's a necklace, let's say it's a chain, let's say it's a silver chain. What he does is, he uses electroplating to apply gold in this chain. So it's gold plating. And also I think if you are a fan of exotic cars, car වලට එහෙම ආස නම් Lamborghinis, G-Wagons වගේ වට ආස නම් in Sri Lanka also we have a gold plated G-Wagon. When they import exotic cars, the people who are crazy rich, they also do those things. They gold plate the entire vehicle. i8 එහෙමත් gold plated ඒවා තියෙන්නේ නේ. So you get the idea. That's what electroplating is. Yeah, so that's the idea. Here also that happens. This is not imitation. Imitation is not, it's not proper gold or silver, but here they normally use this to apply gold. This is gold plated silver. This is not expensive as gold, but it's also expensive. That's the idea. Is it clear? So that's basically electroplating. Now, since you don't know all the concepts of electroplating, all the concepts of electrolysis, because for O levels they give a very limited range of electrolysis concepts. Therefore, I'll explain what you are supposed to know regarding electroplating, because understanding everything completely logically it's not actually possible. That's the idea. ඔක්කොම logically තේරුම් ගන්න චුට්ටක් විතර අමාරුයි. The reason is that you don't know all the concepts, right? Therefore, I'll just explain. Okay, you need to know about this. There are years that they have given electroplating questions, complete electroplating questions. Even for term test, I went through a few term test papers as well. They have given a complete question from electrochemistry, which is only from electroplating. They have given a small setup and they have asked questions on how to do electroplating, give me examples, and then if you are doing electroplating, what element should be the cathode, then what should be the anode, what should be the electrolyte. How about the electrolyte? Give me the reactions of the anode, reactions of the cathode, the total cell reaction, everything has been asked, but only using electroplating concepts. Is that clear? Then let's see what we can do. Then will the gold layer come off faster? No, it depends on how you do the electroplating. If you electroplate properly, then it can't fade. The gold layer can't fade, but with time anything can fade. It depends, the duration depends on how well the electroplating has been done. If they don't apply gold properly, then there are issues. And also regarding gold, regarding a smooth gold plating, there are concepts of smooth electroplating. We learn those as well. Now let's say this is a gold chain. I'm just still giving you the basic idea, right? If this is the gold chain, a silver chain, and now you are expecting to electroplate it, one goldsmith can actually electroplate a very smooth or a very homogeneous or a very uniform layer. It's very uniform. But someone who, if he doesn't want to make it look nice, that person can, now this is the silver necklace, that person can apply gold like this here and there. We have a very small amount here, then we have a lot here. Then you have a little bit like this. So this is also electroplating, but this is a good outcome. No, this is not a good outcome, right? Then we learn what differentiates between this and this, because here it's again silver, gold coated silver, and here also it's gold coated silver. But there's a significant difference when it comes to the outcome. There are a few factors regarding theory on how this difference happens. Then we'll discuss all of those. Now you have a basic idea on what electroplating is and how that can be used and what sort of questions can be asked regarding the anode cathode. So we'll see how the theory works. Good. Now it's actually happening like this. This is the procedure. Let's say you want to apply, zinc. You want to apply zinc, a layer of zinc. a layer of zinc in copper in a copper block, let's say something like this. Generally, for electroplating, we will be coating, the element which is used for coating, no need, this doesn't matter. So just assume that you need to do this, right? You need to apply a layer of zinc in copper. Then what happens is, what you want to do is, and here also there was a comment saying there on the chat that we generally apply elements which are more reactive. So the element which we use to apply the layer should be more reactive. It's not necessary. Why isn't it necessary? Can someone answer that question if you understand what I'm asking? What I'm asking is, now there was a comment saying that if you want to electroplate a layer, then that element of the layer should be more reactive or more, so basically it should be high on the electrochemical series or the activity series than the block. It's not necessary. Why isn't it necessary? Any answers? Why isn't it necessary? Also tin is being applied to iron, that's true, but that's an example. I want the logic. Why isn't it necessary? Yeah, exactly. Yeah, those are examples. Now, if that's necessary, then you can't definitely apply gold on an element, because gold is very on the very bottom of the activity series. Then that's again not possible. True, but those are examples. I am expecting the logic. How do you know that that's not necessary? How do you know that's not necessary? Okay, we'll discuss that later. Hari, we'll discuss that later. Okay, here, now let's say you want to apply copper on zinc. What we do is this. We take the block of copper. We take the block of copper as the cathode. This should be the cathode. This should be the cathode. This copper. This is copper. The block which we want to apply the layer should be the cathode. And the element which we are expecting to apply as the layer should be the anode. This should be the anode. Now in this case, this should be zinc and this should be copper. Check whether that's clear. Make a zinc vela, meya copper venna one. I'll to a certain level teach why. Right? Then what happens, and also the electrolyte, this is important. The electrolyte should be the metal ion of the anode. So basically a metal ion of what needs to be applied. So what needs to be plated or what needs to be covered. Okay, so that's important. Now the basic concept, that's the main thing which you need to understand, even without logically understanding. If you can just study it. Basically the block which we are expecting to apply a layer, which we are expecting to do the electroplating, should be on the cathode, and the element which we are trying to apply or which we are trying to paint or which we are trying to plate should be on the anode side. And also the electrolyte cannot be something random, it should be the metal ion of what is on the anode. Harid? Those are the main three things. Then we'll see how it works, and then we can straight away go to a note. Now how are we going to assign the cathode and anode? Can someone remember? Can someone explain? Now how are we going to make this the anode and make this the cathode? Can someone explain? Is it something to do with the activity series? Yes or no? This becomes anode depending on where it's on the activity series. Yes or no? This becomes the anode depending on where it is on the activity series. Is it a yes or no? Others? Okay, good, finally. It's a no, right? How can that be a yes? That's a no. Why is it a no? Because we are still doing electrolysis. You need to understand what's happening. This is electrolysis. What is electrolysis? The basic point of electrolysis is that, now check your note, you need to remember these are very important. Now that can be asked as a question. zinc is the anode simply because it's on top of the activity series. No, it's not relevant here. Why? For electrolysis, the anode and cathode will be determined by the what? By the terminals of the power source which we are going to plug in. Is that clear? Is it true? If this was an electrochemical cell, then true. But for an electrolytic cell, you need to remember these are very important points. That's why I'm highlighting it again and again. Here we don't care about how they actually want to react. We force them to do what we want to do. Therefore, the anode and cathode is determined by the terminals, the positive or the negative terminal of the cell. Now, what is anode? Now, since you don't know, now again here using now you can just remember that this is plus, this is minus, but I'll again use the logic which I explained. Now, since this is anode, what's happening? Electrons will be removed. This is anode. Anode is for oxidation. Now you have to remember. Cathode is for reduction, which means electrons will be accepted. Now you can see, then the electron flow should be happening like this. This should be the electron flow, right? This should be the electron flow. Therefore, the opposite side should be the opposite direction should be the what? Current flow. Then the current flow will be anti-clockwise. This will be the current flow. To this to be the current flow, how should be the terminals placed? Something like this. Then this is plus, this is minus. Why? Because if it is like this only, the current flow will happen like this. So without studying, only using logics which I taught you, you can easily derive this. Therefore, this should be the setup for the experiment. If this is plus, this is plus. If this is minus, this is minus. Or else, what most of the students do is that they just study that positive is for anode and then do, but I don't like it. It's up to you, but no need to study. Then this is the basic setup for the experiment or for the electroplating practical. Then let's try to understand what happens. Now, if this electrolytic cell, now I'm going to ask you questions. You need to answer. Try to answer properly. Tell me. This is aqueous. This is aqueous. Is this clear? Is this okay? Check whether this is okay before I give you the note. We need to discuss few more things, but before that, check whether everything is okay. Check whether if you have questions you can ask. Because this can be confusing simply because you don't know all the theory. Okay, doesn't matter. What's the solution used as? That's what I said. It's zinc 2 plus. It can be anything which contains zinc 2 plus. So it can be zinc nitrate, zinc sulfate, zinc chloride. Doesn't really matter. It matters, but at your level doesn't matter. Some solution which contains zinc 2 plus can be used as the electrolyte. The idea of the electrolyte is that the metal ion of which what is on the anode side. Then we learn the reactions For these reactions, that's what I checked. You can't use the logics under the logics which we understood on the last session for the reactions of electrolytic cells. Why? Because as I said, those logics or those rules were derived looking at your syllabus for reactions which are on your syllabus. Hari. When it comes to a more general or a practical case, those rules cannot be used. Now, if I can just sum up what we did under the rules. Let's say we had zinc nitrate here. Let's say we had zinc sulfate. Oh, we have zinc sulfate inside this container. We have zinc sulfate. Then what ions do we have? We have zinc 2 plus. We have sulfate. Then we have H plus. Then we have OH minus. Now, if you want to get the cathodic reaction or the reduction, what do we do? Only which ions are eligible for the cathodic reactions? Can someone tell me quickly? For the cathodic reaction is accepting electrons. Then who will accept electrons? Positive ions or negative ions? Quickly. Yeah, the positive ions, right? Always it's about the positive ions. Now you need to remember what I said. Hurry. Always it's the positive ions. Then when it comes to the positive ions, it will be zinc 2 plus and H plus. Then how do we know whether it's zinc 2 plus or H plus? What was the logic? What's the logic? Quickly. If you have zinc 2 plus and H plus as contestants, you need to know whether zinc 2 plus will reduce or H plus will reduce. What's the logic? Yeah, the reactive table or the activity series. Then what is on top has the more tendency to oxidize, and what is at the bottom has more tendency to reduce. Then what's at the bottom? Is it zinc 2 plus or H plus? Is it zinc 2 plus or H plus? Quickly. It's H plus, right? Then according to our logic, H plus should reduce. But actually here zinc 2 plus will reduce. Then you might wonder how. Because there are various other factors which we are not discussing, because the only factor they are asked to discuss is the activity series. That's not the only factor. That's why you can't use those logics. So you need to simply memorize a certain bit which cannot be done using logics. Because they have given on a limited, but at A levels you can. A levels then here what's happening is no need to think of logics, you just need to understand what happens. Okay. At the cathode, what happens at the cathode is this ion will reduce and form a metal, form the metallic version. Zinc 2 plus will accept 2 electrons and form zinc solid. Is it clear? I'll just write this physical states, but not necessary to write. Zinc 2 plus will reduce at the cathode. The reduction will happen at the cathode, right? And then form zinc plus. So what happens practically is this will reduce, forming zinc. That zinc will be plated here, because this is the cathode. The reduction should happen here. So this reaction will happen here, and that zinc will be plated. Not here. It cannot be plated here. Plated, nah. It will be only plated at the region which is being dissolved in water, right? Is it clear? That's the cathodic part. Right. This will be reducing and getting plated like this. Right. Good. Then what happens is the oxidation. The oxidation part. What's the oxidation? The oxidation is that now, since this zinc 2 plus is going this way, this zinc 2 plus will be reduced and go and get plated at the cathode. Then the zinc 2 plus concentration is this in this electrolyte will be what? Will it decrease or increase, or will it be constant with time? The zinc 2 plus concentration in this container with time, will it decrease, increase, or be constant? It will decrease. Why? Because the zinc 2 plus will be reducing as zinc and going here and getting plated or getting covered. Then to replace that zinc 2 plus, to cover the deficit, zinc here will oxidize and be zinc 2 plus and get added to the electrolyte. That's what happening. Now methanol zinc 2 plus, this will get reduced and go this side, which will decrease the zinc 2 plus concentration in the electrolyte. Now that's an issue. That's not possible. You can't do that. You will learn why at A levels, but for the moment that's not possible. That will give you errors. The concentration here should be fixed. It cannot be decreased. Therefore, to fulfill that requirement, to cover the deficit, zinc from here will oxidize and get added to the solution as zinc 2 plus, which is done like this. Right? Which is done like this. That will happen where? That will happen at the anode. May balan? That will happen at the anode. Therefore, the anodic reaction is the anodic reaction. Sorry. The anodic reaction or the oxidation is that zinc oxidizes as zinc 2 plus. So you can see basically both the equations are same but written in the opposite way. That's always common for all the electroplating. This is the oxidation happening at the anode and this is the reduction happening at the cathode. Is it clear? Doesn't matter for every metal the equations will be given like this. We'll discuss few more examples, but for the moment this is the general example. Then we'll try to write a small note, then I'll give you one more question to do on your own, then we'll see whether that's whether you can answer it. Okay. Then since you have written down the topic electroplating, quickly before drawing a cell, write these three important points. Write these three important points, put one star or put important and write these 3 points which is important. Then you can draw the cell. Okay, put a star mark and write. We'll quickly move on. The first point, the object to be plated. The object to be plated, which is this one. The object to be plated should be the cathode. The object to be plated should be the cathode. The object to be plated should be the cathode. That's point 1. The second one. Anode should be the anode should be the anode should be what should be the anode? The anode should be a rod made of rod is just thing like this, a rod. The anode should be a rod made of the metal that is plated. Anode should be a rod made of the metal that is plated, which is we are going to plate it here. We are going to apply zinc. Therefore, anode is a rod made of the metal which is being plated. Is it clear? Okay. The third point. The electrolyte, the third point, the electrolyte. The electrolyte is an aqueous solution. The electrolyte is an aqueous solution. The electrolyte is an aqueous solution. This is the electrolyte. The electrolyte is an aqueous solution containing a salt. Salt is not sodium chloride. Salts are these. Lavana kiyala kiyanne not lunu. The electrolyte should be an aqueous solution containing a salt of the metal of the anode metal should be an aqueous solution containing a salt of the anode metal. Sorry? Of the anode metal. Clear? Right, good. After understanding those three important points, we'll write this cell as example, put example 1, and then write under that example 1. Electroplating zinc on a block of copper. Electroplating zinc on a block of copper. Actually, electroplating zinc is known as galvanizing. Normally, galvanizing is done for iron. So, we will be electroplating zinc on a block of iron, which we learn later. I won't tell you the theory again, but you will learn that as a practical application later. Hari? Good. So, under example 1, write electroplating zinc on a block of copper and then draw this cell. Don't write everything, just draw the two rods, draw the cell with the positive and negative terminals, mark the anode and cathode, mark the electrolyte and say that there's zinc 2 plus. That's it. Don't write anything else. Don't write all these arrows and everything. Just draw a small sketch, a neat sketch. Hari? Okay, once you draw this, now you need to explain how the reactions happen in your own words, and you can write the equations. If you just understand, you can simply write the equation. Now, what's the equation like? What are the equations? At the cathode, this zinc 2 plus near the cathode will reduce, forming zinc, and that zinc will be applied here. You can write it, not just writing this, then you won't understand anything. This zinc 2 plus in the container or in the electrolyte will reduce near the cathode, because that's where the reduction happens, and that reduced zinc, this part will be electroplated here. That's the electroplated zinc. This is electroplated, which will ultimately reduce the concentration of zinc 2 plus here. Therefore, that zinc 2 plus should be fulfilled. The requirement for zinc 2 plus should be fulfilled. That zinc 2 plus requirement will be given by oxidizing this zinc. That zinc is this one. This is the zinc rod. This is the zinc rod oxidized. This is zinc 2 plus in the electrolyte. This is zinc 2 plus in the electrolyte again, but that will be reduced and be electroplated. So you need to explain the entire story while writing both the equations. Just don't write it down, then you won't understand anything. Hari? Okay, if you want any guidance, you can ask. Hari? Good. So, won't the negative sulfate ions in the solution get oxidized? No. In our syllabus, we don't consider about the oxidation of sulfate. It doesn't happen. It's a difficult process. That's what I said. Since you don't know the entire theory, since you don't know all the rules, for electroplating, when it comes to a general application, you don't try to use the logics which we learned. Don't try to use all the logics, because simply we don't know all the logics. That's why. Not because the logics which we are using is wrong. Hari? Karanna දෙයක් නැහැ. For A levels, this won't be an issue. For A levels, we know almost all the logics. Then you can apply those. Hari? But here we don't know. So for a general, so for an example on your textbook, if they give a normal cell, which we gave on the last session, we had 4 example electrolytic cells, right? Under those, you can use the logics which I gave you. But here, don't use those, because this is a more general case. You don't know everything. Simply write this zinc 2 plus is from here. This zinc 2 plus is the electroplated zinc 2 plus. This zinc is from this rod that gets oxidized and it comes here. So you need to write everything, not just writing the equation. Right? Then I'll give you one more example. I'll give you one more minute and then I'll give you the next example which you will be writing answers. Okay, if that's okay, if that's understood, you can write the explanation. If you have questions, you can ask. Okay. Then write example 2. If this is okay, write example 2 and write electroplating gold on silver. Electroplating gold on silver. Now the equations aren't on your syllabus because normally we don't use gold and silver. We don't normally write equations for gold and silver, but you can write. Not difficult. I just want to give you a different example. Electroplating gold on silver. Now the symbol for gold is Au and the cation of gold is Au plus. Right? Also the symbol for silver is Ag. The cation for silver is Ag plus if that's required. Now what I want you to do is I want you to draw a cell, identify what is cathode, what is anode, and then how the terminals of the cell should be, what is positive, what is negative, and then I want you to write all the cathodic and anodic reactions, understanding what happens. And if that's possible, then you have completely understood how to do the electroplating part. Is that clear? What should happen? Gold should be plated in a block of silver. Try. Check whether that can be done. After getting the answer, put it on the chat. You can't put the diagram, just say this is the anode, this is the cathode. Try to do it. oxidation of the metal ions into yeah, true. Normally we use the metal for anode. What's the equation for? No, you no need to write a salt for now. Since gold is being electroplated, the solution or the electrolyte should be a salt of gold. No need to write a salt of gold. You can just write Au plus is inside the container. No need to write whether it's Au sulfate or Au nitrate. You can. But since you asked the question, what is the equation for gold cyanide? So the anion cyanide is Cn minus, which you need to know. If the cation is Au plus, then it's in AuCn. Thing like this. Might not look familiar because you haven't written these frequently. That's why. So you can write let's say if you want, you can write Au sulfate, then it will be a 2 here. You know why, right? No need to put a bracket. It's just Au2. But for the moment, since we don't normally deal with compounds of or salts of gold, you can just write Au plus as the electrolyte. Then how is the cell? What is the cell? Since we are plating gold, this should be Au plus. The electrolyte should be containing a salt of gold. Therefore, this should be Au plus. Then the object which we are applying the gold should be silver, which is the cathode. This is the cathode. The gold, the element or the compound, the element, the metal which we are using to plate should be the anode, which is gold. I gave you all the important theory points using that. This is the anode. Right. Then what determines what is the anode or the cathode is that simply this. The cell. The power source will determine who becomes the anode and the cathode. Therefore, since this is the anode, electrons will be. I am not going to remember anode is this, cathode is this. I am just again using logic. Anode is the place where oxidation happens, where electrons being removed. This is the cathode, electrons being accepted. Therefore, this is the direction of the electron flow. Current flow direction should be the opposite, which is the clockwise direction. This is the current flow. To this to be happening, then this should be positive and this should be negative. Therefore, the current flow happens like this. Good. Since this is positive, this is positive. Since this is negative, this is negative. Right. That's it. You can simply draw it, right? Then now using this, try to write the Cathodic and Analytic equations. Good. I can see a lot of answers. Good. Okay. Quickly write the equations. So what are the equations? What are the equations here? For the cathode, it's simply reducing what is on here. Here it's Au plus, this is being reduced to Au and that will be applied, that will be electroplated here. Now this Au will be reduced to Au by taking one electron, because 1 plus needs 1 minus. Then this will be reduced and plated here. To fulfill the requirement, fulfill the deficit which is created here by decreasing this Au plus, this Au here will oxidize and get into the electrolyte. That's happening in the anode. Therefore, the anodic reaction or the oxidation reaction will be oxidizing the Au here as Au plus. That's it. So you can see everything is similar, right? Only the names of the metals will change. Always the concept of cathode, anode and the electrolyte is the same. Always all the reactions look the same. From the previous one it was zinc to zinc, zinc to zinc. Here it's gold to gold and gold to gold. That's it. Right. So draw the cell. Most of students send the answers, which is good. Others check what went wrong. Then I'll give you one more example and that's it for electroplating. give you 30 seconds. Right? It's clear. Everything is fine, eh? Audio, video, just confirming. The audio is not weird as in the first day of the seminar, and the video is also okay. If you have any issues, just let me know. I can fix it. Then that's good. That's good from my side as well. Okay, thank you. Everything is great. What did I say? Alright, so if this is done, example 3, right, example 3, electroplating copper on a block of copper. Electroplating copper on a block of copper. Example 3, electroplating copper on a block of copper. Now you can draw the sketch for this, draw the setup for the experiment. But meanwhile now, since you know the logic, you know what's the cathode, what's the anode, and what the electrolyte should be, and you can easily write down the equations. Now the cation for copper is copper 2 plus, which you need to know. But while writing and drawing the sketches, writing the equations, think why this makes sense. Now why do we need to apply copper on another block of copper? What does that do? Why is it even necessary? Now, applying gold on silver makes sense. Applying zinc on another metal makes sense. But why applying copper on again copper? Think about that. Hari, I'll ask. But before that, answer the question and identify what is cathode, what is anode, how the cell terminals work. Answers clear. continue. To protect the copper block. Then why copper? If you want to protect the copper block, you might be referring to some concepts like galvanizing. Then you could have applied zinc. Why copper? So that's not the answer. Why copper? I copper magane. And actually copper can't protect the copper block. Why? So now later you will learn this protection is done by sacrificing the layer which we have electroplated. So the protection is something like a shield. It's a cover, right? Now, so answering that question, now there's an answer saying that we are applying copper, a layer of copper for copper to protect the block. To protect the block. But that's not possible. Now the idea on that protection is something like this. Now if you have the block like this, let's say you have copper, then you electroplate another metal, another element which is more reactive like this. Then when corrosion needs to happen, it won't corrode copper because simply the electroplated element is more reactive, then it will corrode that element. That's how the protection happens. Now if you apply copper, then there's a situation where copper can be corroded. Then if this corrodes, then this should also corrode. So you normally can't protect the element by applying the same element, because then if that can be used, if this shield can be corroded, then the element will also corrode because both are the same element. Then that won't be protected. Right? Always this protection will be a sacrifice of that metal. To protect this metal, the other metal will sacrifice by corroding itself. So the same element can't be used. We learned that under corrosion later, so that's not the answer. Any other answers? Now I know you can get the answer easily, you can get the diagrams easily, because this is the third example. Since both are copper, no need to worry, both anode and cathode are copper, both will be copper, and the solute should be, or the electrolyte should be something, a salt of copper. You can write copper sulfate, mostly we use copper sulfate, which is light blue color. Let's say this is the anode, and this is copper. This is the cathode and this is copper. Even though both are the same, you need to number, and so you need to name these, right? Since this is the anode, electrons will be removed like this, electrons will be accepted like this. So this is the electron flow, therefore this is the flow of current, then this will be plus minus, this will be plus minus. Is it clear? It's clear, right? Okay. And then how to write the equations? What are the equations? The equations will be this copper 2 plus will reduce and go and get electroplated here. This will be, normally the sketch won't look like this, right? We want electroplate rods now, let's say. It's on your textbook, you can check. If you are electroplating a nail, the entire nail should be inside the electrolyte, right? If some part is not inside the electrolyte, then it won't get electroplated. Now if you want to electroplate this entire thing, then the entire thing should be submerged. It should be submerged. Otherwise, how can it get electroplated? I'm just drawing a simple sketch. You can check your textbook. Then how will the this is the reduction. Copper 2 plus will reduce and get plated here. Copper 2 plus goes to copper. Then that's 2 electrons here. 2 electrons. Clear one. That's the reduction. This is the Cathodic equation. And for the anodic equation, it's oxidizing copper here as copper 2 plus. Now you know the same thing repeats, ne? Amaru ne? So 2 electrons here. You can't add these two reactions and get the total reaction, then everything will be cancelled out. But it's not the practical case because different. The copper here is copper here. The copper here is copper on the rod. But you can't add these two. For all the equations, for all the cells, you can't add and get a total reaction. Right? No need to do so. So these are the reactions. Now my question is, why is this practically used? What's the importance? It doesn't make sense right now. You can just write the answers, but trying to practically answers. Now they can ask, give a practical application. Why do we use this? Why is it important? To make it more lustrous. A better one? This is very important. This is a very important one. Now, when I say, right, when I say metal which we are electroplating, so the metal which we are expecting to plate should be on the anodic side. Should it be a pure metal? Should it be always pure? Can it have impurities? Can it have impurities, or should it always be pure? Now, since we are going to apply this copper on this side, should this copper rod be 100% pure, or can it have impurities? Should it be always pure? Can it have impurities? Inert impurities, which are substances which do not react. It contains dust, it contains sand. Inside. Now, when you get metals from earth, when you get metals after excavation or some sort of extraction, it won't be pure, right? It contains impurities. Now, what I'm asking is, for this copper rod, can it contain impurities? That's why you can't answer the question. It can contain impurities. To remove those impurities is the actual use of this cell. Now, I'll explain how that happens. Right? I'll explain what I'm meaning. Let's say you have a copper sample which has impurities. Now, in this copper sample, there are impurities. I am marking these impurities. It can be dust, it can not actually dust, it can be some compounds which do not react in this case. Compounds which do not react. Now, apart from these parts, all the others are copper. Now, you need to remove these impurities. The most basic way to remove impurities is just wash it. But these impurities can't be removed by washing. Then you need to use some sort of electrolysis. That's what we are doing here. What happens is, you put this impurity, the solution which contains impurity, the copper solution here, as the anode. This is the anode. Then on the other side, you will use a block which is pure copper. This is pure copper. A block which we previously purified. This is the cathode. Now, can someone explain what's happening? Now, I have given you the idea. Can you now understand what's happening? Can someone explain what's happening? What's happening? Now, why is this important? Now, do you understand what's happening? No? Here, it's actually not about electroplating, even though we learned this under electroplating. The main objective is not to electroplate copper. It's to gather the pure copper to the pure copper block. We collect all the common elements, all the same elements to one place, something like that. Right? We are gathering all the coppers to one place and making a pure copper block. Then we can sell it, or then we can use it for other purposes. That's the main objective here, not electroplating copper. Correct? Here we have impurities, here we have impure copper, and we are removing those impurities and we are extracting the pure part, the real copper part, and then we are going and plating it here. Then we have a copper block which is pure, which has more copper now. That's what we are doing here. Is it clear? Yeah, it's actually refining. It's actually refining this part. Now, how does this happen? Now, you have impurities. Since I said that those won't react, those impurities shouldn't react, right? If those are reacting, then we have to use separate methods. But here, the impurities don't react. In your question also, they will say. Now, this question can be easily asked. Explain how to refine a sample of copper which contains impurities. Then you need to remember, this is about that electroplating part, even though that's not that direct. Right? Then what happens? What happens is, the pure copper in this side, the pure copper, this part, the pure copper, this the pure copper, that will oxidize because this is the anode, that will oxidize as copper 2 plus. And that pure copper part will go and get dissolved in the solution. Is it clear? Then in the anode, that copper 2 plus will get reduced, in the cathode, that copper 2 plus will get reduced and get plated around this copper block, making it a larger copper block. Method which a copper 2 plus we get it oxidized and get it here. So we basically remove that part, that's the extraction. And we can't just keep it here, therefore we get it reduced and get it plated here. Then you have a larger pure copper block. That's what's happening, and that's why this is important. So here it's not about actually electroplating, it's about gathering all the pure parts. So you might wonder, now can't we do this using another metal here? You can, then, but that won't. Then that's again gold plating. That's again electroplating. But here the main objective is not to electroplate. It's not to plate some metal or cover a metal with another metal. It's just to gather the copper here and paste it here, making it a larger copper block. Then you can use it. Now if you had a 500 gram copper block, now you have a 600 gram one. That's the purpose here, right? Okay, so you can write this down. What's the actual purpose, how it is being used practically. You can write it in a way which you understand. That's enough. Dagamuko. Is it clear? Is everything okay? Can someone confirm if is everything okay? Is everything fine? Teranada memo? Or are you just writing it down? Can you understand or not? Good. Teranada ne? Others? Is this understandable or is it difficult? Can you understand? Maybe logically okay? Does it make sense? Good. Yeah? Most of the students are replying that it's understandable. If it is not, let me know, right? Because I'll explain it again. Right? Okay, write it down. With that, we have completed electroplating, and with that we have completed electrolysis as well. I'll give you one more minute, then we'll move to the next main topic. We'll try to finish it at 11:50, then we have roughly 1 hour to do questions. Then let's continue. We'll do the next part. And the third main topic. Corrosion of metals. Doesn't matter. Corrosion of metals. Clear, right? Okay. Under that, mainly we will be discussing on corrosion of iron. If you want, you can write it. Mainly we will be discussing on corrosion of iron, which is known as rusting. Rusting. Write down the topic, then we'll continue. Also, corrosion of steel is known as rusting. Sorry. Yeah, actually, I missed that. Thank you. Thank you for remembering. Now here, one point I missed. I told that in the beginning, but I missed it. Now here on your textbook, they expect us to know how to do a quality plating, which means how to apply the plate or apply the metal in a smooth, uniform way. The only thing you need to know is that the concentration of the electrolyte should be a low concentration. Hari, it's given in the textbook as well. Yeah. The concentration of the electrolyte here should be low. Why? So you can just put a star mark and write this under electroplating, then I'll explain. Put a star mark and write. Put a star mark and write. Just copy the textbook. It says concentration of the electrolyte should be low. Concentration of the electrolyte should be low to have a high quality plating. Why is that? Concentration of the electrolyte should be low to have a high quality plating. Why is that? The reason for that is, now if you have a very high concentrated copper 2 plus, then you will learn, I think you know this, right? I think you know this. When the concentration of the reactant is high, what increases? You know this. Let's say you have a reaction between sodium and water. If you want to make the reaction rate increase, what will you increase? You can increase the size of the sodium. Then what happens? When you increase the size of the sodium, the concentration will increase. Then automatically the rate will increase. So we know that, right? For all of us, you do that. So if you increase the concentration of the reactant, then the rate of the reaction will increase. Then when you increase the concentration of the electrolyte, or else here if you increase the concentration of copper 2 plus inside the electrolyte, then the copper 2 plus going to copper, the reduction will increase here. If you increase the copper 2 plus concentration, the rate of this reaction will increase. Make a very වැඩි වෙනවා. Then it's good ඉක්මනට පුළුවන් කරගන්න. Then you can apply the metal and you can quickly finish the electroplating. Then why isn't it good? Then why won't it be a high quality one? What will happen is when copper 2 plus gets applied quickly, it won't get applied smoothly and evenly. Assume a scenario that you are painting a wall. Science is nothing new, science is just day-to-day life. Assume that you are painting a wall. You can either just take whatever amount of paint to the brush, you can just dip it in a way that you want, and then you can just apply it here and there, then you can quickly finish it. Will it be even and will it look nice? No. If you properly observe a good paint, a person who is painting a wall, who is skilled, what he will do is he always know how much he should need to dip. And then also, he will remove the excess amount by just applying the brush on the bucket. then only he will start painting, and he will do it in a very even and a smooth way, slowly. Then only it will look nice, even though it takes time and effort. That's what I am mentioning here. So if the concentration here is high, what happens is it will quickly go and get plated, and it would look nice and even. That's why. So you get the idea. I'm not just writing the note. You know practically what's happening. Then even though you forget it, even when they ask it for the paper, you can just think about it. Now, okay, there was something like this. You can write it. That's what actually I want you to do. Hari, is that clear? Is it clear? You got the example. Simply remember how to paint a wall. Then you will understand this. Painting a wall, you will understand. Same thing. Just painting a metal on a metal. Hari? Same idea. Hari. Then you can write this. Explain that thing on your note regarding the quality electroplating. Then come to this part. Right? Good. Then let's start this part. This part is not difficult except for the rusting equations, and how to prevent equations can be a little bit tricky if you don't understand it. Other than that, the majority of the content is regarding the experiments, which are really easy. Not the only one experiment containing the experiment which is regarding cathodic protection. If you can remember in the latter part, it's difficult. It needs to be understood a little bit. Other than that, the experiments are really easy, not difficult. The first thing is that regarding rusting or corrosion, so we'll be mainly discussing about rusting. There are two primary factors which is necessary, which is required for rusting. What are those factors? Can you quickly tell me what are those factors? The first few experiments will be regarding those two factors. What are the factors for rusting? Here man, tuggle. I want answers quickly. Tuggle. Yeah, one thing is it should contain water vapor. Right? Water is required, not water vapor. It's some form of water. One is water. Okay. Other. What is the other one? Yeah, the other one is oxygen. The other factor is oxygen. These two are the main factors of rusting. You need to have both. We'll explain it later, right? You need to have both. Without having both, you can't make the rusting happen. Right, that's what we are going to understand here. Is it clear? Okay. So the first part is that we are going to understand that oxygen is necessary. How are we going to do that? We will give all the conditions same. Now you know when you are doing experiment, you need to have the control experiment and the main experiment. Then you can do the comparison. I think you have a general idea on how an experiment is done. Here what we are going to do is we will give water to both the experiments to show that only having water is not enough. Since we are testing for oxygen, we will give air for one experiment, and the controlled experiment won't get air. So that's the basic idea. I'm just explaining logically how to remember equation, how to remember experiments, not just the first experiment is this done like this, not like that. Alright. So the first one is, no need to write any topics. We'll just first of all draw the sketches, and then we'll see what we can do. Alright. Right. The first experiment is something like this. Here we have a test tube. Which contains water. This is water. And also we have another test tube which contains water. Right, so the same conditions. This is the controlled experiments. Now we are going to make few changes. The first thing is that we are going to boil this water. This water is boiled. right? This is boiled. Right? This is boiled water. Right? And also we are applying a layer of coconut oil, or let's say oil for the moment. We are applying a layer of oil. In both of these experiments, we are submerging a nail. This is the nail. Okay, a nail. Hi. Oh, look, nail. We are submerging a nail. Hi. Now, what's happening is, in this, the nail gets corroded, but here it doesn't get corroded. Then we need to analyze what are the differences. Now, this has water. This contains water. What's the difference here, and how did that difference occur? Can someone explain? What's the difference here, and how did that difference occur? Due to what changes? This is the first experiment. No need to even write this down if you want, because everything is given on the resource and it's not difficult on the textbook. What happened? What's the reason? Okay, so here it's a lack of oxygen. You can say so. How do you know exactly? Or else, how did that happen? Why don't we have oxygen here? Can someone explain why don't we have oxygen? Okay, right, good, exactly, that's the correct answer. Correct, very good. What's the answer here? And yeah, you can write coconut oil in your textbook because it's given as coconut oil, so you can write it, no issue. The idea here is that once you boil the water, always all the gases, after boiling to a certain point, always all the gases which are dissolved in a liquid will evaporate once you boil it. You learn why later. When you boil a liquid, there are gases dissolved in that liquid, those will evaporate. Therefore, in this water, there are no gases. But gases can again enter from the atmosphere. Preventing it, you have used a blocker, which is the coconut oil layer. Normally, gases do not travel through coconut oil layers. That's the idea. You get it? Otherwise, this is not possible. Then, in this container, you don't have air. You don't have atmospheric air. You can't exactly say that air is oxygen. How do you know whether that's oxygen? It can be nitrogen even. Someone can say, no, it's nitrogen. You don't know. You can't confirm. Right? Always pay attention to the practical side. You might know that it's oxygen. Now, they can give this experiment. Now, these are the points students get wrong. They can give this experiment and say, what is the conclusion of this experiment? If someone writes, oxygen is necessary for rusting, wrong. How do you know whether it's oxygen? It can be nitrogen in this experiment. You need to say, air is necessary for rusting for this part. So, this is not the only experiment. This is not complete to get a complete conclusion. You need to do a few experiments to understand what component of air is necessary. That's another part. Here you can say, for this experiment, for the controlled experiment, it had both water and it had air. There are two resources of air here. One will be from the atmosphere, and always in the water there is gas. For this side, by boiling the water, that gas was removed, and also new gases cannot enter due to this coconut oil layer. Then you don't have gases here. Since this didn't get rusted, you can conclude that what? Having air or a component of air, which we don't know what the component is. A component of air is necessary for rusting. So this is the first experiment. If you want, you can draw a small sketch and explain what the conclusion is, and explain how we know that air is not here, because by boiling, air went away and coconut oil won't let air to be entered. This is the first experiment. I'll take 5 minutes for each experiment and quickly revise the experiments. If you want, I'll give you 1 minute. Okay, enough. The second one, no need to write any topic, just get the idea. Second one, now we need to identify which component of the atmosphere actually matters. For that, what we are going to do is, we are arranging a separate experiment which is like this. This is water. These are two boiling tubes. Now you need to know these names. You can't just write tubes, because in practicals you need to be specific and accurate. Boiling tubes. Alright, this is water. This is water. Here, instead of a nail, we will be using iron wool. Iron වලින් හදපු නිකන් කම්බි කියලා හිතන්න. Iron wool. It's iron wool. Here we use nothing. Nothing is being used in the controlled experiment. With time, what happens is the observation. And always know when you are writing observations, you need to know the difference between conclusions and observations, right? You can't say for an observation hydrogen gas emitted, as we discussed under electrochemical series. How do you know electrochemical series? How do you know that's hydrogen? You can say a gas emitted or air bubbles were seen. You get the idea, right? There's a difference between an observation and a conclusion. You need to know those things, right? Right. ඇහැට පේන දේ තමයි observation එක කියලා කියන්නේ. Right? ඇහැට පේන දේ is the observation. Now for an example, if I take another example, let's say, yeah. Now when you see a white color light, you can't say, sorry, let's say a red color light. When you see a red color light, you can't say a wavelength of this much emitted. How do you know? How did you do the calculation? You only saw the red light. Afterwards, you can do the calculations for red light, and then if you know the equations in A levels, you can get the wavelengths, or you can get the frequencies. You know V equals F lambda, right? So you can use that and get the answers. But by looking at the red light, you can't say this frequency is emitted. That's not the observation. That's a conclusion. So you get the idea, right? Okay. Can identify it by sentence? Yeah, that's what I'm going to do here. Now what's happening here is, the idea of what's happening here is this iron, right? That's why for the previous one, we can only say a component of air or air is required, is necessary for rusting. That's what we can say. Here we are going to identify what component is necessary. With time, what happens is, you can see the observation. The water level here is rising, and it will be something like this. The water here has rise like this. What is being said is, if you measure the level rise, if the length of this tube from here to here is L, the length of this is L over 5. Basically what I am saying is, the amount which has been risen is 1/5 of the amount which is on top of the water layer. Water layer එකෙන් උඩ තියෙන එකෙන් 1/5 වලින් water වලින් පිරෙනවා. Is it clear? Which is 20%. What happens is, now you can arrive to a conclusion of on what we know, using what we know. We know that 20% of the atmospheric gas is oxygen. 20% of the atmospheric gas is oxygen. Now what actually happens here is, right, what actually happens here is this. The iron here uses the oxygen which is inside this container, inside this tube, to rust. Iron here uses the oxygen here inside the container to rust. What happens is, since iron uses that 20% of oxygen, there will be a deficit of 20% of gases. Is it clear? Now if we say that the volume of this tube which is remaining here is 100, 20 of that will be oxygen. That oxygen will be consumed for the rusting part. Therefore there will be a space, a 20% space will be removed now. There will be a 20% space which can be filled. Therefore water will rise up to that level. Water period. That's what's happening. So that can be concluded. You can conclude that oxygen is the component of air which is necessary. So you need to be able to write it. What you are supposed to write is, the observation is this. 1/5 of the remaining tube was filled by water. That's the observation. The conclusion is that since we have 1/5 of, since the percentage of oxygen in the atmospheric gas is 1/5 or 20%, we can conclude that the oxygen was required for rusting. Therefore, there was a 20% space was created. That's why water filled up that 20%. Is it clear? Okay, if you want you can write those assumptions. Everything is clearly given on the resource or the textbook. Therefore I'll just revise everything, but I'll give you 1 minute if you want to write anything. If you have questions also you can ask. This is just a revision part, nothing difficult. This part is the third main topic, is not difficult actually. Now we have confirmed that oxygen is compulsory. Right? Right. Good. Then the third experiment, the third experiment is to actually confirm whether water is compulsory. We don't know yet, right? For both experiments, the first one and the second one. For both the control and the main experiment, also we gave water, since we don't know whether water is a factor. Right? The third one is to identify whether water is a factor. Right? What we do here is I'll just copy the textbook. For this part, actually referring to the textbook is the easiest thing because no logics, it's just purely knowing what's happening here for the first few experiments. What has been done here, again we have used boiling tubes, the controlled experiment and the main experiment. The tubes have been sealed, and they have used two nails, one nail like this and the other nail like this, just to confirm whether there is any impact on the side or the surface area, which we will be proving that there is no impact, doesn't matter. Then again this will be sealed, again we will be using two nails like this, right? But here we are using anhydrous. What's anhydrous? Does anyone know anhydrous calcium chloride? What's anhydrous? Both of these are boiling tubes. Sorry? Tell me what's anhydrous? Yeah, water has been removed. Water has been removed. No water. There's no water. That's the meaning of anhydrous. Now what happens here is, what the difference is, here since this is sealed and these two containers have been, or these two tubes have been boiled, we don't have air inside this. Therefore no need to worry about you can't say there can be air, even though you no need to boil it. There can be air inside this. There can be. So this side you have air, this side from the atmosphere you have air, also from this side you have air, and from the atmosphere you have air. You can't prevent it. There can be air. But since you have sealed the tubes, water vapor cannot enter. The water vapor from the atmosphere cannot enter. And also, this anhydrous calcium chloride has a tendency to absorb water, especially when it is anhydrous. It likes to absorb water. Since we have removed the water, it will try to absorb water. What will happen is, the water inside this tube, whatever the water vapor inside this tube, we don't have water, then it should be visible. We can have water vapor. That water vapor will be absorbed to calcium chloride. Then inside this tube we don't have water vapor. Here we can have water vapor. That's the only difference. Nothing to do with air, because air can be inside the tubes. Since we have water vapor, we have water vapor here, and we have oxygen here. This part will rust. Since we have oxygen here from the atmosphere and water vapor obviously from the atmosphere, this part will also rust. This is the controlled experiment. For this one, we have water vapor from the atmosphere, also we have oxygen from the atmosphere, therefore this part will also rust. But here, even though we have oxygen, we don't have water vapor, therefore this part, these two won't rust, which confirms that having water vapor or some form of water is also compulsory. So that's the next topic, that's the next requirement. You need to have water, some sort of water. That's compulsory. So you can write down experimental important points. The other question, why can't we use copper sulfate? You can use some substance which is hygroscopic. What's hygroscopic? A substance which can absorb water. That's hygroscopic, so you can use. Doesn't matter. In your textbook they have given calcium chloride, that's why I use calcium chloride. The names of the tubes are boiling tubes. So there are separate types of tubes, therefore you need to know what type of tubes we are using. So that's the third experiment. Now we know what factors does govern rusting. You need to have water, you need to have oxygen. Okay, quickly write down, I'll give you 1 minute. I'll actually give you 2 minutes. Check whether everything is understood regarding the reactions, the equations, not reactions, the equations, the factors. We'll not continue the order on your textbook. We'll finish all the experiments first, and then we'll get into theory. Right? I'll take 30 minutes roughly to finish this part. Take a look at your note up to now. I'll give you 2 minutes. Right, okay. Can apply COCl3. If it's normally it should, yeah, should be okay. But when you are writing answers, stick to what is given on the textbook. Copper sulfate is generally used, that's fine. Okay. Then the first three experiments were to understand what factors are necessary to make rusting happen. Now we are going to understand the factors which accelerates or decelerates, which increase the rate of increases or decreases the rate of rusting. Right. For the first three, you can write a main topic if you want. Requirements for rusting. For the first three experiments, the topic should be requirements for rusting. For the next three experiments, the topic will be factors that increase or decrease the rate of rusting. Factors that increase or decrease the rate of rusting. Therefore, you need to understand for this topic always, for all experiments, water and oxygen should be present. Now we are accepting that rusting is happening, and then we are going to understand whether it's happening in a slower rate or a faster rate. The first thing is we are going to understand the effect of acid, whether it decreases the rate or whether it increases the rate. For that, you are using something like this. You have three tubes. On one you have cold water. I am simply writing what is on the textbook. Cold water. You have a nail. Then you have water mixed with lime juice. Sorry, not this one. Yeah, come on. No need of this also. I can simply eliminate one. If I have the I'll just use one. No need to draw three tubes. One is necessary. Here it's diluted HCl, diluted hydrochloric acid, HCl, which contains, since it is diluted, you have water, so it's water and HCl. You have a nail. Then it has said, according to your textbook, the rate of rust, both will rust. Why? Both has water, both will get oxygen. Therefore, both will rust. But they have said, if we consider a given time period, this will rust more. Therefore, you can simply conclude that acids will fasten up or will increase the rate of rusting. This will increase. So, these are very simple experiments, right? You just need to have a basic idea and then you can write anything. It's easy. So, the speed will be increased by acid. I'll give you like 30 seconds if you want. You can write anything. It's very simple experiments. Alright. And there's a small issue. Later we learned that bases will. Okay, I'll tell the issue later. We just continue. Okay, we'll see that later. So this is easy, right? Okay. The second experiment is regarding bases. The first one is acid. The second one is bases. For that one, we are doing the same kind of experiment. The first one is cold water with a nail. The second one is base, let's say NaOH. They have used sodium hydroxide. aqueous which contains water and NaOH, then with a nail. Both have oxygen and water. You need to figure out that. First of all, you need to have oxygen and water, otherwise rusting won't happen. We have nothing to do with this then. Hari? Both have oxygen and water. Then what happens is that considering given time period, they have said the rusting in this side has, the nail on this side has rusted more, which means what? Normal water will have a rusting rate than a basified water, which means adding a base will decrease the rate of rusting. It's the opposite of acids. It will increase, acids will increase the rate, bases will decrease. Now there's an issue. On the previous experiment, they have said, if you observe page 105 on the textbook, I don't know whether pages are same, they have given another tube which contains lime water. And they have said that the speed of rusting has increased by adding lime water as well. But actually lime water is calcium hydroxide. Which is again a base. I don't know whether that's an issue. Eka chuttak hoyala balanna if you want, because they have said for lime water they have given lime water under acids, which is again wrong. That's a base. And they have said the rate has been increased, which cannot be possible because for bases we learned that it's decreased. So if someone knows what actually happens there, or whether it's an error, because I'm not aware about your syllabus actually. I know only chemistry, I don't know the syllabus for all levels. You can just confirm if someone knows, or just check what happens. Right. Maybe the lime water is lime. Yeah, so it's lime juice. Actually, lime juice is again calcium hydroxide. It's a base. Just Google what lime juice. It's calcium hydroxide. Like normally lime water, lime juice, both are the same typically. So it's lime juice, not lime water. Is lime juice not calcium hydroxide? Lime. Okay. Lime juice. You mean the actual juice? That's citric acid. Right. Sorry, my bad. I didn't take it that way. You normally use the term lime juice. Right. That's citric acid. Right. In normal chemistry, lime water, lime juice is calcium hydroxide. We normally don't use the term lime juice, but I took it like that. Right. Okay, so my bad. So lime juice is dehi bima කියන එක. Okay. Right. So that's citric acid, then that makes sense. Right? Lime water is calcium hydroxide. Then that makes sense. Here it's lime juice. In all levels, lime juice is dehi bima. Yeah. Then that's citric acid, right? Then that makes sense. Then the third one. So basically, for acids, the rate is being increased, and for bases, the rate is being decreased. Finally, it's salts, the effect of salt, not salts, salt. It's not all the salt, this salt. Now you use salt, the term salt for various things. No, previously for electrolytes and electrolytes, salt is a compound which is derived by reacting an acid and a base. If you react an acid with a base, you will get a salt. That's something else. There are salts for all the metals. There are salts of zinc, zinc sulfate, zinc nitrate. Those are salts. This is salt which we eat. Now we are analyzing the impact of salt. What happens is, again they have used a simple experiment like this. Like the same kind of experiment. They have used ordinary cold water. It's just cold water. And on the other side they have used what have they used? Sodium chloride, diluted sodium chloride, which contains water, then, or else aqueous sodium chloride. This nail and this nail. Here the rate is higher. It has corroded in a higher percentage. Therefore, you can say the impact of salt or sodium chloride has It does increase the corroding. And it does increase the rate of corroding. Now, if you are living near a coastal area, you might know this. I have this experience. If you have a, let's say, I can't say, should be, yeah, not a, if you have a, offended never, I have this experience. If you have a low end car, නිකන් මරුටි එකක් වගේ තියෙනවනේ. හරි ඉතින්. quality එක අඩුයිනේ always in a Maruti, right? It's a cheap, now it's not cheap, but when I had the experiment, it was a cheap car, it was affordable. The Maruti එකක් තිබ්බ කියලා තරහ වෙන්න බෑ, low end කිව්වා කියලා ඉතින්. Low end නේ. If you have a car like that, and if you are living near a coastal area, it will corrode. It will start to rust. You can observe it. Our car assaval near the tires or the places which has openings start to corrode. Right? So there's a significant, now corroding a car is something big name. Therefore there's a significant effect of sodium chloride. Now when you are living in a coastal area, you don't live with salt always, but the wind contains components of sodium chloride, and the water vapor contains sodium chloride near a coastal area. Therefore if the car is not a high quality car, then it starts to corrode. I have that personal experience. My parents used Maruti Suzuki like 15 years ago when I was small, and then that actually happened. But when you switch to a better car, that won't happen due to the quality, it simply stopped. Right? But you can observe it if you, I don't know whether it applies for nowadays Marutis, but I had that experience. So you get the idea. Even not only for cars, if you have metal, let's say window frames, normally we use aluminium to avoid that, but if you use metal window frames again, or metal, let's say furniture or whatever, it will start to corrode if you are living near a coastal area. Right? So this can be normally observed in day-to-day life. The others you normally don't observe, acids and bases, but this normally can be observed. Right? Good. So those three are the factors. Salts will increase, acids will increase, and bases will decrease. Bases will decrease. Hari, is it clear? Good. Are there any reasons? Yeah, actually there are reasons. I'll try to explain it using the equations. Since we haven't learned equations, I'll explain, but those aren't necessary. The question is asking that, can you explain like logically or using chemistry why acids and sodium chloride increases the rate and why does bases decrease? I'll try to explain it, but you need some knowledge on equilibrium, not the equilibrium you learn. You learn static equilibrium. Now you learn when you hold the pen like this, the force acting downwards and the force acting upwards is equal, therefore this is in equilibrium. That's known as static equilibrium. In A levels you learn dynamic equilibrium, it's different. So you need to know a few concepts regarding that, but I'll try whether it's possible to teach how these factors think whether they are going to increase it or decrease. Anyway, so those are the main 6 experiments regarding corrosion of iron. Corrosion of iron. Check whether everything is okay before we continue. Then write the next main topic. Equations of rusting. After learning equations of rusting, you can learn how to prevent rusting, and that's it for this part. Then we can continue doing the tute. We'll have roughly 45 minutes to do the tute, or if I think I'll extend it to 12:15. We'll have roughly 1 hour, 45 minutes. Let's say we start at 11:30, then still we have 45 minutes. What's the topic? Equations of rusting. Equations of rusting. Put the topic. Am I a little bit slow today? I'm really tired. That might be the reason for being a little bit slow. I don't know whether I'm speaking a little bit slow. My brain is not properly processing today. The reason is that I think most of you are aware that I'm still an undergraduate, right? I'm doing engineering, and I'm doing civil engineering, right? So we have in all types of all types of engineering, not only for engineering now. You might be interested on how actually engineering looks like. Like I'll give those ideas later when you join A levels. But if you're willing to become an engineer, when you train, when you do the degree, not for engineering, for medicine, for nursing, for whatever the profession, you have an intern period, which can be known in various different names, right? Normally in medicine it's intern or clinicals. This is difference as well, but normally those terms will be used. Now for us it's interns. In the intern period, you have to serve as a trainee for a company. So it's inside our degree program. So I haven't graduated yet. I have like roughly 1.5 years to be graduated, but we have that degree. We have that. I have to serve as a trainee for a company or for a government enterprise. And when I'm serving during my 6 month service period, I have to do night shifts. They don't care whether I have classes or not. That they don't know even whether I'm doing classes. That's something separate from that. So when they say come and work a night shift, I have to do it. So when I planned the seminar, I didn't have the night shift. But when they say come and work, that's how it is. So you need to work hard. You need to commit. I think that's the commitment I am giving from my side. Now when I said that the seminar is from 9 a.m. to 12 noon, that's a responsibility which I am taking, right? Okay, now students are getting ready to learn from 9 a.m. to 12 noon. I might even not know you. I might be doing this for free, but still that's a responsibility. Then they suddenly say, come and work a night shift. Not only yesterday, on the Wednesday also I did a night shift from, normally night shift is from 10 p.m. to 6 a.m. So I did this on Wednesday, and then I did this on Thursday as well, which is yesterday night. Normally this didn't end at 6 a.m. This went until like 10 a.m. Anyway, and then I had this from 10 p.m. to roughly 5 a.m. It ended a little bit earlier, luckily. Then I came home and slept for like 2 hours and then got ready for the seminar, and then I'm doing it. That might be the reason. I'm just feeling, I don't know whether it's visible, but I'm feeling that poddak idara amaru, right? It's like little bit dizzy, poddak idara thiyana, right? And also tomorrow I have like 10 hours of classes. Tomorrow is a Saturday. Normally we have a lot of classes on Saturday. And then also after tomorrow's, I finish my classes at 11:30 p.m. But again I have a night shift tomorrow at 11 p.m. So I can't say, I have classes, I can't attend the night shift, right? Then I won't get the degree. So I have to finish the classes early at around 10:30. I have to start it earlier. Then again I have to get up early tomorrow because I have to start the classes earlier. Then I have to shift all the classes up. Then I have to do it, and then I have to go tomorrow at 11 p.m. and then again from 11 p.m. to right? From 11 p.m. to 6 a.m. again I have to repeat it, right? So it's difficult, but it's actually fun. Now, if you are willing to become a good professional, or if you are willing to become successful, right? Now I'm doing both of these to become successful, right? I'm doing classes to become successful from one side, and I'm doing my engineering program to become successful from another side, right? So that's for myself, right? Then you need to be willing to. I'm not encouraging not sleeping, right? It's not good. I'm not doing this in a regular basis. They won't ask us to do night shift in a regular basis. But whenever they ask us to do that, you need to be committed. Now the same thing for you students. Now you have roughly 10 days for your O levels, right? Don't complain that it's difficult, you are doing a lot. You haven't seen how people work, Hari. You haven't seen how people work, Hari. I am not the person who is working the most. There are students in my engineering faculty who work more than this. Hari, they're not. So understand that if you are no matter what stream you are taking for A levels, if you are not willing to put the effort, if you are not now for A levels, you don't need to do like this. Night shift you can sleep properly, you can function as a proper human. Now I'm not functioning as a proper human for few days. That's something else. That's some separate commitment because I'm doing classes. Otherwise I would have slept now. That's different. That's something extra. But for A levels, if you are not willing to commit in a regular basis, and for these remaining 9 days, if you are not willing to give your most, don't. I'm not asking you to not sleep well, right? You can sleep well and do work in the remaining hours. Hari, that's something different. Don't get the wrong idea. But then you won't succeed. Hari. Always be able to commit. A moral now I am standing here simply because of the moral, right? Otherwise I can't stand like Zamaru. It's difficult. And even in the night shift, you are not just watching and sitting. You have to assist the laborers. You have to work with them. It's really difficult to work with the laborers. Those people aren't properly educated. We need to scold them. It's difficult, and they shout at us again. Who are you to shout at us? You are just trainees. It's difficult, right? Lazy, even in medicine, it's not easy to give medication for patients. It's difficult. You need to deal with them. Always your parents, even though they don't show that it's difficult, they just come home and they check whether you are doing well. They ask questions, and even though they seem to be okay, it's not the case. It's really difficult once you get a job and once you go to the corporate world, or whether it's a business or whatever. It's difficult. Earning money is really difficult. You need to understand that. There's no such thing as easy money. It doesn't matter whether you are doing a business or whether you are doing a job or whatever. Because I'm doing both. I understand it perfectly. Even though you are young, you are still young, you haven't even done your O-levels. Try to understand how the world functions. Always think that my parents are giving the most, they are not complaining, but you need to understand, even though they don't show it, it's really difficult. You can have parents who are doing night shifts for the entire month. Their entire job is doing night shift maybe. You don't know. I'm just saying that I did night shift for 2 or 3 days and I have to do one more day. I can feel how painful it is. Therefore, understand it. You need to know how the world works. I just got the opportunity, that's why I said it. Right? Yeah. I personally know, I don't personally know it, but I know most of the engineering students or medicine students have the same story. Right? Only difference is that we get the opportunity to express it. Okay, then let's continue. Hurry. Right, back to topic. Now forget about these. Just okay. Equations of rusting. Right. We try to quickly finish this. I took a little bit time to talk. Where is it? Okay. Right. Now what happens here is, actually under rusting also we can see oxidation and a reduction. In A-levels we name a place where oxidation and reductions happen is as a redox. This is for reductions, this is for oxidation. Right? So basically under rusting also there is an oxidation and there is also a reduction. The oxidation reaction is, now here you don't know all the concepts. We actually don't know any concepts under rusting. We know only the practical ideas, but we don't know any chemistry concepts. So basically you need to remember the oxidation is Fe going to Fe2 plus 2 electrons, and the reduction is oxygen going to OH minus. Right? Oxygen going to OH minus is the reduction. Now in A-levels we normally don't remember how to balance the equations. There are methods which enables us to balance any equation. So you just need to know the method. Then you can balance any amounts of reactions, but I won't give you the method here because it takes time to learn the method and it's not necessary to learn the entire method when you want to just remember one equation. Here it's easier to remember it, right? So it's a balance like this. You put a 2OH minus, then after balancing everything, I won't show you how to balance it. I'll just write down the equation. So basically, I don't know the equation. Why? Because I am used to balance the equation using the method. I don't know. I have to just copy the equation which is given here. O2 plus 4E goes to 4OH minus. This is the reduction. Is it clear? This is the reduction. So we have the oxidation and the reduction. Then you can add these two in a way that the electrons are cancelled. So this should be multiplied by 2. Then this becomes 4E. And then this 4E will get cancelled out. Right? So the final reaction will be 2Fe plus 2H2O. 2Fe plus 2H2O plus oxygen goes to 2Fe2 plus. If you can't write it just looking at this, you better multiply this by 2 and then straight away add this. Doesn't matter. Hurry. I'm just doing it simultaneously. 4H minus. Hurry. Then this is the final equation for rusty. We had the same we had the same reaction for acidulated water. This one. So I showed you how to balance it, ne? I showed you how to balance it. Under acidulated water, we had the same equation. Not only for that, for few we had this equation, I guess. I can't remember exactly. No, it wasn't this. Was it this? I can't remember. I don't remember equations like that. I just know the concept. I think you have understood it by now. Ne? In A levels, we get used, a student who is performing well gets used to not remembering everything. He just know the concept. So when I am walking in the road, if someone asks, what is the cathodic reaction of this? I don't know. Right? I can't remember. I just need to draw the cell and then logically think what's happened. Something like this. So I can't remember whether even we had this. Anyway, after getting this, this is the equation. This can be written as everything I'm just writing. I'm just copying the textbook now. For this part, nothing new, nothing difficult. You can write this entire part as FeOH2. This is ferric. This is known as ferrous hydroxide. Ferrous hydroxide. Here you can see that we have 2 Fe's, therefore this should be 2. And also we have 4 OH minuses, which makes sense, right? 2 into 2 is 4. We have 4 OH minus. So this is the compound which we get under ferrous hydroxide. So you can combine these two and write it as ferrous hydroxide. And this won't remain like this. Normally Fe2 plus won't remain stable in the atmospheric conditions. It will try to further oxidize to Fe3 plus, which has also been shown on your resource. What happens is something like this. Again, they have given. So for this part, it's easier than understanding to balance the equations because these in all of us they haven't taught. That's why actually these things are a little bit difficult now. If they could teach you how to do a redox reaction, then these things will be easy. But they haven't. Now I won't take time because it contains some time. No need. So it's they have given it straight away. H2O plus 2H2O. I'll just explain this compound. So this is a solid. This part is a solid. This part is a liquid. And you have a 2 here. Right? Yeah, otherwise it's not balanced. Sorry. And you can see, I'll just explain this compound. This contains Fe3 plus. This Fe2O3 contains Fe3 plus. I guess you will be able to understand it looking at the numbers here. I think you know how to write the formulas using the using the valencies. And can someone explain, even though we have water, how this is a solid? How does that make sense? Now here you have water and it's a liquid. But here you have a water and you have a dot also and you have solid. What does that make? What does it mean? No, it's not ice. No, that's not ice. You said the final equation, is it accurate? Say final is accurate. It's accurate? This is so. Yeah. For the previous one. Okay, yeah. True. Not for this one, the acidulated water. Okay. What does that mean? We have few more compounds like this. In A level, this is a common compound. Na2H2O3. This is known as sodium thiosulfate dot 5H2O, but again a solid. What does it mean? It's not ice. It's not ice. Water vapor, then it should be gas. How does this become solid? If you keep your table salt, the salt which we eat, if you make a small pile of sodium chloride salt and keep it somewhere on a table, what happens after 2 days? If you observe it, what happens? What are the observations you can get by observing a sodium chloride sample which is just kept in a table? Yeah, there's an answer which is close. It will melt. Can it melt? It's not melting. But when you touch it, you can feel it's like a liquid now. But it's not liquid. It's solid, but it's a little bit wet. You can see, you can feel it. You will feel it. There's a difference. It's වතුර ටිකක් දාලා වගේ එකට. What happens is some compounds are hygroscopic, which means they can absorb water from the atmosphere, like calcium chloride. Okay, no? When it absorbs water up to a certain limit, it can remain as a solid without dissolving. Now, if you add a little bit of sodium chloride to a water cup with a lot of water, then it will dissolve. But you don't have a lot of water, you have a lot of water in the atmosphere, but everything won't get absorbed. So, up to a certain limit of absorption, sodium chloride will remain as a solid, but with water inside. That's what is. This is not sodium chloride, this is for another compound, this is the same. So, this is ferric oxide. Ferric oxide will remain solid with some water inside, which is written like this. You need to understand what's happening here, just don't write equations. Now, this equation needs to be memorized, which might be a little bit difficult, but put some effort. Most of the seminar wasn't about memorizing, and now this part, it's easier to memorize than understanding how to balance these equations for the moment. Right? In A levels, we can learn how to balance. So that's regarding the equations of rusting. Basically, there are 3 equations. The first one is the oxidation, Fe going to Fe2 plus. The second one is the reduction of oxygen going to OH minus. Then finally, forming this in the final equation. And then finally, Fe2 plus is further oxidized into Fe3 plus. That's it. So this is the actual formula of rust. This is the formula of rust. Fe2O3. This is rust. If they ask you to write the formula of rust, this is it. It's actually difficult to explain why acids, bases and salts increase or decrease the rates, because I thought of it simply not knowing how equilibrium or how kinetic chemistry works. It's difficult to explain, so no need to make it complicated. Those things will be explained in A levels. If you want to know, do A level chemistry. Okay. Quickly copy this and then we'll continue. We have one more topic. I'll give you one more minute, then you can go to the final topic. final topic, preventing rusting. Preventing rusting or prevention of rusting. Prevention of rusting. Prevention of rusting. Right, so there are various methods you can use to prevention of rusting. So you can basically apply oil. Now, if you can remember the first experiment, by having a coconut oil layer, it prevented the gases entering. Therefore, you can apply oil. You can apply some. There are rusting prevention. Let's say coatings, substances, paint, various types of paints. Those things are given on the resource book very briefly. Therefore, I won't explain those. There's a very important method regarding prevention of rusting, which is known as the cathodic protection. Which involves concepts of electrolysis, which we did previously. I'll teach you that, right? Because that's the part which they have explained the most. Right? Okay. There's a question. Is it with F2 auto? I'm not sure. I haven't thought of that. I can't remember. Buddha calling Belu. I can't remember. Tell again. If you want, put it send a WhatsApp message. I think I watched Breaking Bad very Buddha calling Belu. Alright. Now the experiment, cathodic protection, the experiment. They have given an experiment on your resource book, on your textbook, and I'll explain that first, and then we'll check what needs to be understood regarding that. Hari, I'll copy all the 5 experiments. You can check your textbook as well, because simply here I'm just copying all the things which are on your textbook. Alright, the 4 and then 5. You have 5 containers, and you are using agar jelly. What's agar jelly? It's a medium. It's a medium which we use to do practical experiments. In all 5, that medium is agar jelly. Right? All 5, it's agar jelly. I won't write it for all 5. I'll just write it here. The medium is this, and also we are using phenolphthalein, we'll learn why, and also potassium ferricyanide. Okay, those are okay. And you have 5 nails. You have 5 nails. You have 5 nails, and also this one is just a nail. This is a nail with a piece of magnesium attached to it. Piece of magnesium. The nail is iron, The nail is iron. All 5 nails are irons, because we are talking about iron corrosion. This is a piece of zinc. This is a piece of copper, and this is a piece of something which is again less reactive. What is it? Lead. Okay, doesn't matter. Lead. Now this is everything. This has everything to do with the activity series. Activity series saying make it. And also we have added phenolphthalein and potassium ferricyanide, right? Now here, phenolphthalein, I'll just explain this because these haven't been explained in your textbook. Phenolphthalein is an indicator. There are a few types of indicators in A-levels. You will learn how an indicator can be made and how actually an indicator functions. But for the moment, and there are various types of indications, one type of indicator is acid-base indicator. Acid-base indicator. Therefore, this indicator will show you whether the solution contains acids or bases. Now for phenolphthalein, you know, if the medium is acidified, then it won't show any color, it's colorless. If it is base, it will show you pink color. Right? So whenever phenolphthalein turns to pink, we know that the medium is acidified, which is used here. That's one thing. And also potassium ferricyanide, right? Potassium ferricyanide, ne? Potassium ferricyanide. This is an industrial name or a trivial name. There are two types of names in nomenclature for chemistry, which is IUPAC names, which are standard names. These are just day-to-day names. Nicknames This is a trivial name. Those are known as trivial names, not IUPAC names, for a compound which is this potassium ferricyanide. It should be Fe2, then if this is Fe, this is K3. Yeah. This is the formula. No need to know this, I'm just showing you what things can be known later. This will be done on the A levels. This is potassium ferricyanide. Yeah, this is ferricyanide. Hari, this is potassium ferricyanide. Is it clear? Now what happens is that this potassium ferricyanide will show a blue color, with the presence of Fe2+. If Fe2+ is inside the container, then it will show a blue color. So we are expecting two types of observations. The first observation is if phenolphthalein becomes pink, then its OH- has been produced, or a base has been produced somewhere. And if this becomes blue, then Fe2+ has been produced. Right? You need to know this before understanding what happens in the experiment. Right? If you want, you can write this to somewhere before looking at the next slide, other slide. Right? If Fe2+ is present, this will show you a blue color. If OH- or a base is present, this will show you a pink color. Those things need to be understood. After understanding those two, look at this experiment. Now here you have just a nail. And then the experiment will be something like this. We'll take two colors, this for this side and for this side, like this. Now, here colors use we can use blue and what's the other one? Pink. Do we have pink? Alright, good. Now what happens is, for the normal nail, it will be pink here and it will be blue here and blue here. Now what has happened is OH- has been formed and also Fe2+ has been formed. Now if you are wondering how that happened, if we check the previous slide regarding equations, now can you see that I am teaching the lesson in a way which everything makes sense. Now this is not the textbook order, that's a speciality. Right? I maintain a separate order which everything is perfectly neat. Now we finish all the experiments, then we did the equations. Now we are using those equations to understand how to prevent. That's the proper order. That should be the proper order, right? Methana, you can see here Fe2+ has been produced and also OH- has been produced. So if a normal rusting happens, in the middle Fe2+ and OH- will be produced. Therefore you should obtain both pink and both blue. You should obtain both pink and blue. So Fe2+ is produced in the oxidation process. You can see oxidation. Now where does the oxidation happen? In the anode. Therefore if you see blue color, that means that part should be the anode on that nail. And here it's OH- being produced, therefore that should be the cathode. Now if we switch again, these two are the anodes. Now we'll write it somewhere else. Pink is for OH- which is produced in the cathode. We'll just write it looking at the equations. Blue for Fe2+, which is produced on the anode. Now for this nail, these two parts are acting as the anode and this part is acting as the cathode. Now you have a perfect understanding. Now looking at the observations here, this part is purple, so or else pink, but you can't see any blue color. Here also the same observation, but for these two the observation should change. You can see purple color here, sorry pink color here, but also you can see blue color in the nail. Now before we continue, can someone say, looking at all 5 experiments, if I name all 5 as 1, 2, 3, 4, 5, tell me in which experiments, in which containers has the nail corroded? Tell me the answers. Monati keda corrode vela tiyenne. Is it one from 1, 2, 3, 4, 5? Can you quickly tell me? Out of the 5 containers, on which containers has the nail corroded? Okay, 1, 4 and 5. Good. That should be the answer. 1, 4 and 5. How do we know? Because if the corrosion happens, always Fe2 plus should be produced. Then there should be a blue color. So just looking at it, you can say it's 1, 4 and 5. Therefore, in these 2 containers, corrosion hasn't been happened. Why? We learn why now, right? Now that's the concept. This is the experiment. By learning this, you will learn a special term, which is the cathodic protection. This is the experiment to show how cathodic protection works. Now what has happened is, here since we only have one metal, always the water inside this container has done the reaction, the OH minus thing. Somehow the nail is acting as both the anode and cathode, because simply we only have the nail, we only have Fe. Therefore the nail is acting as both the anode and cathode. Here the nail is acting as the cathode. We'll just write Fe is the cathode here. How do you know? Because it's for pink. Pink is for cathode. The nail part is acting as the cathode. Here also the nail is acting as cathode. Fe cathode. But you can see here it's blue, which is the anode. The nail is acting as the anode. Fe is anode. Nail is acting as the anode. Here also the nail is acting as the anode. Now you can see clearly. Now this is just the control experiment. You can ignore it. No point. Now considering these 4, you can see here Fe is the cathode, but here Fe is the anode. Can someone explain why? That will explain the entire concept. I have broken it into few parts. Quickly tell me why anode is cathode. So why Fe is cathode here and why Fe is anode here. What are the reasons? Yeah, using the activity series, you know that. Now we learn those concepts using the activity series. Going from top to bottom, the tendency to oxidize is higher in the top, and in the bottom, tendency to reduce is higher. If someone likes to reduce, then that will be mostly the cathode. If someone likes to oxidize, then that will be the anode. Now if I take the activity series for these 5 elements, which is Fe, magnesium, zinc, copper and lead, you need not to remember the entire order, but it's something like this. Fe is here. If Fe is here, you have copper and then you have lead. Something like this. No, it's the other way, sorry. After Fe you have lead, then you have few more elements in the middle, right? I'm not focusing about those. And here you have magnesium, then you have zinc. Something like this. So you can see, looking at the reactivity series, the tendency to oxidize for these 2 is higher and these 2 is lower. So whenever you have Fe with magnesium, magnesium likes to oxidize because it's on top. Then magnesium will oxidize. Then here magnesium will be the anode. Therefore Fe will be the cathode. Because Fe is the cathode, what happens on the cathode? It will reduce. Therefore Fe won't produce Fe2+. Now does everything start to make sense? I'll explain again. If you combine Fe, if you combine iron with a metal which is more reactive, which likes to oxidize, then that metal will oxidize. Therefore Fe can't oxidize. Then Fe can't produce Fe2+. Then Fe will act as the cathode, allowing oxygen to be OH-, which is the cathodic reaction. Now here the same story. If you couple Fe with zinc, which is more reactive, zinc will oxidize, preventing Fe oxidizing, which is Fe being Fe2+, eventually rusting. True? For these 2, this is the case. For this one, copper is less reactive than Fe. Therefore Fe will oxidize. That means what? Corrosion will happen. Eventually corrosion will happen. So Fe2+ has been produced. Right. Here also the same story. So the basic idea of preventing the cathodic prevention is, Fe can be plated. Fe can be plated with a metal which is more reactive than Fe. Therefore, instead of corroding Fe, that metal will sacrifice itself by corroding itself. Then what happens is, once you see that the protection layer is being corroded, you need to remove it and replace it with another layer. Now let's say, if you want to protect this iron can which is made of Fe, you can galvanize it by applying what? By applying a layer of zinc. Applying a layer of zinc using the electroplating method which we learned previously. Then, when it wants to corrode, instead of corroding Fe, zinc will start to corrode. Then you can see, okay, zinc is getting corroded, then I need to apply zinc again. It won't harm the iron team. That's how cathodic protection is done. Since we are using iron as the cathode and a more active one as the anode, this is known as the cathodic protection. Iron is hiding as the cathode, preventing it from oxidizing and eventually corroding. That's the idea. So you get the idea, right? If you want, you can just write the important points, so you can ask the concepts, but everything is given on the textbook. See, after I explain it, now reading the textbook will perfectly explain everything. Otherwise, it might be a little bit complicated. So that's the idea. Hari? Okay, I'll give you 2 to 3 minutes. If you have questions, you can ask. If not, that's it from our side regarding theory. We have roughly 30 minutes, 30 to 40 minutes. We'll try to do a few questions here and there. Then you have a good idea, and then you can afterwards complete the entire tute. Most of the questions on the tute are past paper questions. Therefore, you can easily check the answers as well later. The recent past paper questions. So you need to be able to say what's the anode here? Magnesium anode. Fe is the cathode, then what is the cathodic reaction? You know the production of OH minus. We have written the cathodic reaction, you can write it O2 going to OH minus. Then here what's the anodic reaction? Fe going to Fe2. What are the anodic reactions here? The anodic reactions are simply oxidizing these two. Here it's magnesium going to magnesium 2 plus, zinc going to zinc 2 plus. That's the anodic reaction. The cathodic reaction is O2 going to OH minus, this one. Which we wrote previously. Cathodic reaction, this one. This one, where is it? This one, the cathodic reaction. This is not happening because now it's not the anode. That's for these two. But for this, the cathodic reaction is actually the previous one, O2 going to OH, that's the same. But the anodic reaction here is Fe going to Fe2 plus. Here also it's Fe going to Fe2 plus. Therefore, that's rusting happening. If you have questions, ask, or else we can continue. If this is not perfectly clear, then you might have not read about this previously. You might have no idea. Then you can, when I send the recording, you can go through it again, or else you can read your textbook, or else you can try to review questions and get your knowledge more solid. Depends. Alright. Then if this is okay, take the tute. We'll discuss few questions. We'll try to discuss 1 or 2 questions. Alright. I'll continue until maximum 12:30. We plan to finish at 12, but I think I can go until 12:30. Check it. 30 more minutes. Full 30 minutes more. Right. If you want, you can drink some water for the break. Now, since we have finished the entire electrochemistry, you can celebrate it for 2 minutes. Drink some water. Get the tube. It's better if you have hard copy. Then we'll start doing few questions. I want you to do, I'll discuss the question, I want you to do the second question. I want you to do the second question on the tube. Try to do the second question. All the questions are equally important, therefore I can't select one, but I just want to do it second one now. Try to do all the questions. Only 5 or 6 questions have been given. I don't have time to discuss everything, unfortunately, as we did in the first seminar. But here, we'll do few. Try to do the second question. I'll give you how many minutes? It's 11:46. I'll give you until 11:55. Quickly do the second question. And send the answers. Once you get the answers, you can put it on the chat. Put the Roman number and put the answer. Right, quickly. 45 minutes. Sorry. You can ask, but better not to ask, because when you're answering a question, it's better to think it and try to guess all right answers because you need to be confident by now. Right? How would we have answers? I gave you a few. Answers. Right, other sources and the answers. I'll give you until 12. If you are done the question, you can do try to do the sixth one. That is from what we did now, the cathodic protection. Hi. So shall I discuss the second one? I got answers from few students, but I want more. Hi. The second one. Hurry. Here's the second question. The cell U shown below is an electrochemical cell, while the cell W is an electrolytic cell, right? You can see the difference, right? What's the difference? That on cell 2, you can see the battery. If you were supposed to connect the cell 1, that would simply be only a wire, right? There's no battery for the electrochemical cells, which I taught you. And you can see zinc electrode, copper electrode, diluted sulfuric acid, aqueous copper sulfate, carbon electrode, okay, fine. Now, Roman number 1, in which cell above chemical energy converted to electro? I taught you that, right? Now, the difference between the main difference between electrochemical cells and electrolytic cells was let's say this is electrochemical. This is the electrochemical cell. And this is the electrolytic cell, second part, with the battery. Right? All the reactions here are spontaneous. Can you remember? Which will happen automatically, no need to force. Looking at the activity series, we can say what will become the cathode, what will become the anode. But here it's forced. Reactions are normally non-spontaneous, which will be forced by a power supply, which is the battery. Therefore, the energy conversion is here. The energy conversion is a spontaneous reaction will happen, creating a battery. Now, this is the battery actually. This is the battery. So, for a spontaneous, now if you put a bulb, now if you have this electrochemical cell, and if you connect both the anode and cathode by a wire, and if you put a bulb here, then it will light up, because this will give you the power. Electrochemical cell will give you the power, which is the electrical energy, right? Which will be the electrical energy. That electrical energy will be given by the reactions of these spontaneous reactions, which is considered as the chemical energy. The chemical energy inside those substances or the compounds will react together, producing electrical energy. That's what's happening here. So the energy conversion is chemical energy to electrical energy. Here it's different. Here is the opposite. Since these reactions are non-spontaneous, those won't happen automatically. Therefore, you will have to provide external electrical energy. That electrical energy will force the chemical energy production. Right? That's the process. So here it's chemical energy to electrical energy. Here it's electrical energy to chemical energy. Now what they are asking is, in which cell above chemical energy converted to electric? This one, it's spontaneously happening. So the chemical energy inside those spontaneous reactions will be converted into electrical energy, forming a battery or a cell. Right? So it's cell U. The first one is cell U. That's Roman number 1. For Roman number 2, so you can write anything if you want, right? What is the name by which the anode reactions occurring in two cells are commonly known? What does that mean? What is the name by which? Oxidation? Is that what they are asking? Yeah. So simply they are asking that what do we call the reaction which is happening in the anode? Doesn't matter whether it's electrolytic or electrochemical cell. If oxidation happens, if oxidation happens, that's known as the anode. So in anode always oxidation happens, in cathode always the reduction happens. That's Roman number 2. For Roman number 3, indicate the half reaction occurring at anode of cell U by a chemical equation. Right. Now as you can see, considering cell U, In cell U you have a zinc, you have copper, and you know logically, we know logically, these questions are very easy questions than what we learned under theory, right? Theory we did lot than this, right? These are very easy. Now they are asking for the anodic reaction. For cell U we are looking at zinc and copper. Then what is on top? Zinc. Considering the activity, zinc is on top. Therefore this will oxidize, that will be happening on the anode. Therefore the anodic reaction is the oxidation of zinc, producing zinc 2 plus 2, very easy, right? State the convention used to identify the anode and cathode in cell W. So in cell W, that's a convention, we know, right? For cell W, it's not natural. So depending on the battery, the terminal of the battery, depending on the positivity or the negativity of the terminal, you can say that's the convention. So simply you can say, now actually I haven't studied this, right? So I have to draw it from the beginning and derive it. So for me it's easy. Here you can see it's positive on this side and negative on this side. On this side it's carbon, on this side also it's carbon. If this is positive, this side is positive, this is negative. Since this is positive, the current will be flown like this, therefore the electron flow will be happening the other way. It's like 15 seconds of the thinking. Now when I'm explaining I take about 30, but when I'm thinking it takes like 15 to 10 seconds to think everything. Since electrons are going away, this is the anode because this is the oxidation. Since electrons are accepted, this is the cathode because this is the reduction. Hurry. Now what they are asking is state the convention used to identify the anode and cathode. So simply you can say the positive end of the battery is connected to the anode and the negative end of the battery is connected to the cathode. You can simply say so. Or else you can say anode is positive or the cathode is negative. Doesn't matter, some sort of a convention. The only difference is we don't study that, we logically derive it and write it as we studied. That's it. We say the positive end is anode or the negative end is, positive end is anode and the negative end is cathode. That's the convention. Okay. Complete up to that point. So you can see it's like a 2-minute, 3-minute question. A lot of marks. I'll give you 30 seconds, then I'll continue the next two parts. Others who are confident with the answers can continue the question 6 as I asked, right? Okay, enough. Fifth part, what change in color occurs in the electrolyte solution when cell W operates? Again, that's easy. You can see cell W. First of all, you need to have an idea on what what the reactions are on cell W. Now we are getting it derived logically. We don't know, we haven't studied, right? We haven't studied. So it's carbon electrode, both are inert, nothing will react. And we have aqueous copper sulfate, which means we have copper 2 plus, we have sulfate 2 minus, we have H plus from water and OH minus from water. And considering the cathodic reaction, we are starting from the cathodic reaction. Cathode will be only considering the positive ions because it's accepting electrons. Therefore, it's this and this. You can see copper is below. Therefore, it has the tendency to reduce, which is happening in the cathode. Therefore, the cathodic reaction is copper 2 plus going for copper. So, you can see without studying anything, and also you can be considered no matter what type of question they give, you can write answers because you haven't studied. You just getting it logically. Then the anodic reaction, again, we are considering the negative ions, but only we are considering about OH minus and Cl minus. Therefore, we simply ignore this. We only have OH minus here. Therefore, OH minus will be going to oxygen, and I can balance this. I put 2 because I have 2 oxygens. Since I have 2 H's, I put 2 H plus. Then the charges will be balanced. The charge here is 2 minus. The charge here is 2 plus. To balance the charge, I put 4 electrons. I said that if you want, you can try to understand how to balance this, or else you can study. These things will be taught under A levels. But since it's easy to balance, you can remember it. OH minus goes to O2. Since we have 2 oxygens, we put a 2 here to make it 2 oxygens. Since we have 2 hydrogens, we put 2 H pluses. Now considering the charge, it's 1 minus into 2 is 2 minus, minus 2. It's 1 plus into 2 is 2, and here the charge is 0. Therefore the total charge is plus 2, therefore the total charge is minus 2. The difference is 4, which we add 4 electrons, because now here it's 0 plus 2, electron charge is minus 1 into 4 is minus 4. This side is minus 2, so the charges are equals. That's what we have done. Even here that's the case. The charge here is 0, the charge here is plus 2, charge is minus 2. Then charges are equal. ඒකට තමයි අපි electrons දාන්නේ. Right? No need to understand those, but if you are interested, that will make writing answers much more easy. Otherwise you will have to remember this. Anyway, after writing the cathodic reaction and anodic reaction, they are asking what change in color occurs in the electrolyte solution when cell W operates. But the answer is that when cell W operates, you can see this copper 2 plus is reacting to be copper, which means the concentration of copper 2 plus reduces. Now here you have what? Copper sulfate. What's the color of copper sulfate? It's blue color, right? When copper 2 plus decreases, what happens? The amount of copper sulfate should decrease. There are sulfates, but the copper 2 plus is decreasing. The color of copper sulfate is given simply because of copper. That copper part is decreasing, therefore the blue color in the electrolyte will decrease. The intensity of blue color will decrease. That should be the answer. That should be the answer. So that's what I say W for the Roman number 5. Explain the reason for it. So you can write the answer. So for the first part is asking the observation. What change in color? The blue color, the intensity of blue color will decrease. That's the change. And it won't become colorless, but it will become very light blue. And then the reason is that the copper 2 plus concentration will reduce. You can show that writing the cathodic equation as well. Write a complete answer, show that this is the cathodic equation, then the copper 2 plus concentration will decrease, therefore the color will decrease, intensity of the color will decrease. The sixth part, which electrode is dissolved when above cell operates? What's the answer? Which electrode will dissolve? Anode or the cathode? Now here also can you remember that you need to rearrange this. You can't keep OH minus because OH minus doesn't properly represent OH minus, therefore you need to add 2H plus on this side, 2H plus on this side and rearrange the equation. Anyways, what electrode get dissolved? On the other side of the tube they are asking which electrode is dissolved when above cell operate. When above cells operate. For this cell, which electrode gets dissolved? Does anything get dissolved? No, nothing happens. Copper 2 plus is from the container, from the electrolyte. Again, OH minus is from the electrolyte. So nothing will happen. As you can see, both the electrodes are what? Carbon. Those won't react. So nothing will get dissolved from cell W. For cell W, you can write nothing happens, but they are asking for both cells. For cell U, you can see, for cell U, we wrote the anodic equation. This is the anodic equation, which means zinc solid will get ionized as zinc 2 plus. So here one electrode was zinc and the other electrode was copper. Nothing happens to copper, but this zinc electrode will dissolve as zinc 2 plus. Therefore, the zinc electrode will get dissolved with time. We learned those observations. We did the examples which I gave you to explain theory were more difficult than this. These are very easy questions, right? So zinc electrode gets dissolved. That's it. ගොඩක් ළමයි ඔක්කොම answers ඒවල තිබ්බ good. හොඳයි යා. Right. So that's it for this question, and then we'll discuss the sixth question. We'll discuss the sixth question. I'll give you let's say I'll give you 10 more minutes until 12:20. Then I'll quickly discuss the question and finish at 12:30. Okay. Send the answers for the sixth question. Then make sure you finish all the questions. Go through the markings. If you have doubts, you can send it to WhatsApp. Ask her. Before we meet on next session, I'll inform the next session procedures. I'll send a Google form tonight asking few suggestions. Then we can continue from here on. Okay. කරන්න බලන්න. have 4 minutes more. Other students also send the answers, then I'll discuss this. Sorry. Also, after the discussion of this question, since we are finishing for today, if you have any other doubts, any other issues, or any other, no, don't send suggestions. I'll send a special form for that, separate form. If you have anything else, you can ask. Sorry. Aladiyan. Okay, then we'll quickly discuss this and end the session for today. Alright, you can see few answers. The sixth question. The sixth question. If you properly went through the question, you can see that it's exactly what I have taught you now, apart from the diagram which they have given. Everything else is similar. All the questions can be directly answers, nothing indirect. Figure 1 indicates how a straight cylindrical iron pillar planted on the bottom of a shallow sea has corroded after few years. Okay. And then the following hypothesis was proposed by a student who observed the iron pillar. Now, when they give such a paragraph, closely read it. Just don't start writing the question answers, even though you might know. There can be hidden hints or hidden tricks we don't know, right? Always read the questions properly. And the observed pillar, iron pillar, right? In places where the contact between iron and oxygen is less, the rate of corrosion of iron is high. Okay, whenever the oxygen amount is less, the rate of corrosion is high. That's what he's saying. To test the hypothesis, the student assembled a setup shown in figure 2 and observed after few hours he could see that the area labeled Q has become blue in color, right? And also, even though you read the first thing is that you need to read the question properly, and always some students get confused or get scared after reading such a paragraph. We haven't learned something like this, we haven't learned iron corroding in C. It's just a diagram and it's just a small explanation. I'm trying to apply whatever the question in a practical way, give it in a practical scenario, as a practical scenario, right? So just read the question. But once you start reading the sub parts of the question, you will understand that it's, even though the paragraph is something new, the questions are all the same questions if you know the theory. That's it. Read the question properly. Hari? The first part. What are the factors necessary for corrosion of iron? We know that. And always when you are selecting questions for O levels as well, read the question properly and determine whether that can be done. If you can avoid cutting an entire question, thinking that I can't do this after writing few answers, then time will be always on your side. Right? Taking few minutes to read the entire question, taking a few minutes to check whether every question can be answered, or at least 50 to 60% can be answered, then that won't be considered as a waste of time. The waste of time will be you answering 3 to 4 parts and then understanding that you can't answer the remaining 5 to 6 parts. Then that's a waste of time. Then you will have to cut this entire thing and this won't get any value. Avoid that, then time won't be an issue. I can guarantee that. Somehow, what are the factors necessary for corrosion of iron? Necessary factors, which is oxygen and don't write air, it's oxygen and water, some form of water. That's Roman number 1. Roman number 2, what species produced by iron rod cause the blue color in area Q? We learned it's Fe2 plus. Fe2 plus produced by. Now you can't write Fe2O3 or else you can't write everything. You need to write, it's moisture, not water. The proper word is moisture. Some form of water, it's moisture. Better moisture and oxygen. And here it's Fe2 plus, not Fe3 plus. Fe3 plus is the actual rust, but the formula of Fe3 plus is this. Fe3 plus is contained as ferric oxide in the oxide form. This is rust. It's Fe2O3 dot H2O. If you can remember the equations which we wrote previously, this is rust. But this is what gives you the blue color, which is produced in the middle of the rusting process. Always Fe2 plus. So that's it. And then Roman number 3, what color could be observed in area P in this experiment? So you know that, right? Now as you can see in the experiment, if Q was giving blue color, then P should give, so then if Q is giving blue color, then Q is the anode which is giving Fe2 plus, and then P should be the cathodic area which should give you OH minus, then the color will be pink. It's either blue or pink, then it's pink. B part, write the iron electron half reaction causing the color you stated above, which is about pink. Now how do they give pink? By the cathodic reaction, which is O2 go into OH minus, and then you can balance it. We balanced it previously. I am talking about this cathodic equation. Where do we have it? Here, maybe. So this one gives you the blue color, this anodic reaction, and this cathodic reaction will give you the pink color. So that's the equation. You need to memorize it or learn how to balance it or write it. So you can see very straightforward questions. Fourth one, what is the use of adding sodium chloride to jelly medium? Have they added? Okay, what's the use? Give me answers. What's the use of adding sodium chloride to jelly medium? What's the use? To make the corrosion happening faster. Why? Then you can observe it betterly. Then you get the idea, to increase the rate of corrosion or corroding or rusting. Why? Then you have a lot of corrode or a lot of rust. Then you can get the observations better. Is it true? Because you have a lot of rust, then a lot of Fe2 plus will be produced, then a lot of OH minus will be produced, then the intensity of the colors is better, something like that. So it's a basic answer is to increase the rate of corrosion. So very easy, right? No, nothing difficult. The fifth one, does the result of the experiment validate the student's hypothesis? Does it? What does he say? In places where contact between iron and oxygen is less, the rate of corrosion of iron is high. Is it true or false? Any ideas? Yeah, it's not that clear, ne? Because there's no proper link between the amount of oxygen and the corrosion. You see, looking at the experiment, looking at figure 2. It cannot be true, right? How can it be true? Yeah, true. That was what I was also wondering now. The upper part has acted as the cathode, but you can't say that hasn't corroded, ne? That's the matter of cathode and anode, ne? Yeah, it should be no. Generally, now it's not that clear looking at the diagram, but generally, then whenever it's not clear, write the theory. Generally, when you have less oxygen, the corrosion should be demoted, ne? I mean, otherwise it should be promoted if the oxygen concentration is high, therefore it cannot be true. And does the result experiment validate? No, it doesn't validate anyway. Anyway, it doesn't validate whether it's false or true. The experiment does nothing to validate it, ne? It doesn't show whether it gets increased or decreased, the amount of oxygen. Anyway, in our theory also, we haven't learned anything about the rate regarding the oxygen concentration. Oxygen is required for rusting, but we haven't learned whether having a lot of oxygen makes rusting, the rate of rusting higher. එහෙම එකක් ඉගෙන ගත්තේ නෑනේ. Oxygen and moisture is required. Acid bases and salts tell whether the rate is higher or low. So anyway, it doesn't validate. So they are simply asking for a yes or no. It's no. 6. State a method used to protect from corrosion the iron hulls of ship which frequently come in contact with. So you know that you can use the Cathodic protection by applying a layer of protective zinc coating, which is known as galvanizing, to protect the ship, the metal ship, iron ship. Explain briefly how the method contributes to reduce corrosion. So you can explain up to a certain limit. You can say that when you apply zinc coating, zinc will be more reactive, therefore that will be acting as the anode, preventing the cathode, which is the iron, from oxidizing, which is preventing it from rusting. So you can write that answer. So you can see the questions are very straightforward and direct. So if you know the theory, if you have the note properly written, if you can understand the concepts with a very minimum memory, you can get a lot of marks. So what I want from your side is, if you have issues, you can ask, and ask it on WhatsApp as well. And if you have doubts when I send the recording, you can go through it again, just the parts which you want to be clarified. And also, when I send the suggestion form, please fill it. Please fill it. And then I can get a lot of ideas from you students, because I am not properly aware of what your students' requirements are, because I am not dealing with all our students frequently. That's why. And then we can continue the next 7 to 8 days, depending on what your requirements are. It can be live sessions, it can be recorded sessions, doesn't matter. It can be short videos, right? It can be something regarding another unit, it can be a question discussion session, whatever. So if a significant student wants some program, I can give it. If one or two students want, I won't give it, then that's not productive from my side and from your side. Then you can just ask the question on WhatsApp, then I can answer your question. Other than that, we can have a separate program if a certain amount of students require the same thing. Okay, therefore that's the important thing you need to know. It's 12:30, we'll finish the session. And what else? And when do we have science? For O levels, what's the date? So we are starting O levels on 16th, right? And it's continuing until 27th. Is it so? It's starting on 16th and continuing until 27th. And also regarding our A-level classes, everything will be informed on the group. We will be starting A-level classes on the first week of April. We will have separate introductory sessions on how to do A-levels, why doing A-levels, and why English medium, and why science and maths, and why not science and maths for students who aren't doing so. It depends on the person. And also we will be having introductory sessions for our classes, so no need to bother about those because students are continuously sending messages asking. We'll inform those later. But I want you to answer is, when is O-level from 16th to 27th? Is it so? Just put it on the chat. 17th to 26th. Okay, the other way. Okay, it's 17th to 26th, right? Okay. Is it 16? 16 to 26. It doesn't matter. Anyway, something like that. Then that's it. We are done for today. So the first two sessions are completely finished. If you have questions, you can ask now, or else you can ask on WhatsApp. Then that's it for today. Yeah, thank you for joining. I'll end the meeting in 30 seconds.